All right, let's wrap this up. Picking up at 24C. How long will it take this rocket we were messing around with to hit 128 feet? When I replace h with 128, I'm looking at 128 equals 16t squared plus 64t plus 80. I'm going to subtract 128 from both sides of this equation in order to set it equal to 0, and then again use the quadratic formula to solve. It's going to be negative 48, I believe. Sure is. I don't want to go further before I check those things. A is negative 16, B is 64, C is negative 48. So my solutions here, which actually has to do with 128, I set them equal to 0 to work this. Negative b plus or minus radical b squared minus 4 times a times c all over 2 times a. Go through my process of simplifying. (64 squared) 4,096. All this is over negative 32. Negative times negative times negative is going to be minus 4 times 16 times 48. 3072. 4096 minus 3072. I'm looking at negative 64 plus or minus radical 1024 all over negative 32. Finishing up here, 1024 is the perfect square of 32, so I'll come back over here. Negative 64 plus or minus 32 all over negative 32. This is going to be positive 32 if I, sorry, got ahead of myself here. Two ways this could go: negative 64 plus 32 all over negative 32. That's going to be negative 32 over negative 32, or 1. So what that's saying is that at 1 second, this rocket will be at 128 feet. I'm going to go the other side. 64 minus 32, all divided by negative 32. 64 is going to be negative 96 over negative 32, which I believe is 3. So some things we know about this rocket right now is that at 1 second and 3 seconds, it's at a height of 128 feet. So just thinking about it in the context of the problem. And now I need to go on and solve part D. And part D, after how many seconds is it launched, will the rocket hit the lake? I'm looking for the zeros. When is this rocket launch that started 80 feet in the air? When's it going to come down and hit the lake? One of these I expect to be negative once I solve. A, negative 16, B, 64, C is 80. I'm going to run out of room on this paper. Here we go. Let's find the two solutions. I know one of them is going to be negative. Negative b plus or minus radical b squared minus 4 times a times c all over 2a. X is going to be equal to negative 64 plus or minus radical 4,096. I had the square of 64 before. This is going to be adding the product of 4 times 16 times 80, which is 5,120. All of this over negative 32. 5,120 plus the 4096 under my radical is going to put me at negative 64 plus or minus radical 9216 all over negative 32. The square root of 9216 is 96. Negative 64 plus or minus 96 all over negative 32. If I do, here we go, negative 64 minus 96 over negative 32, I gotta also find negative 64 plus 96 all over negative 32. Man, add some paper if you have to. This page got a little ugly in terms of room. I got, let's see, I subtracted negative 160 over negative 32. It's 5. And this is going to result in a negative answer. This is what I needed. When, after, how many seconds after it launched will the rocket hit the lake? 5 seconds. And how long will it take for the rocket to hit 128? We had that happening at 1 and 3 seconds. Back this up if you have to work through those. Last but not least, let's wrap this whole baby up. Number 25, your answer is B. 26, your answer is, let's read, the discriminant is less than 0. It's a negative number. If the discriminant is a negative number, I'm going to have imaginary solutions. The discriminant sits under a radical, and taking the square root of a negative number means that I have to factor out an I. And in this case, a perfect square trinomial would be a x minus x plus situation, and you would have 2 real roots. Which of the following is in vertex form? I hope you can pick this one out. That's B. What direction does the parabola open up? Does the parabola open? It's a negative a value. It's going to open down. And which is the following is the perfect square trinomial? Perfect square trinomial, the product of its vectors. I'm recognizing 1/9 as 1/3 times 1/3. Is my b value in the middle? Sure is. My b value in the middle is the sum of 1/3 and 1/3. There you go. That's the quadratic test.